right, good afternoon. How are we all? Good first day? So my name's Chris Auld. I'm from a company called Intergen. We're based out of Wellington, New Zealand, but offices all around the country. Welcome to COS 200. COS 200 is the business of the cloud. It is not the business of spelling. Right? We're going to talk a bit about cloud computing from a business person's viewpoint. I'm a big believer in the idea that cloud computing is not really a technological innovation. I don't think there's a lot of new technical innovation in cloud computing. I think a lot of what the innovation is around the business model. Cloud computing brings a completely new business model to people when they try and procure computing power. Who's had a cloud definition already today? Whoa. Who wants another one? Alrighty, so my definition is that cloud computing is a model for the procurement of computing resources whereby they are purchased as a utility and consumed over the internet. Now, I have the occasional argument with people about whether the internet is truly the right word or whether we should be using the word network. But the focus of today's session is really around this idea of procured and purchased as a utility. Right? And I think that's really, to me, the key economic driver for what cloud computing offers in terms of differentiation from what we've done before. Because we've had virtualization before, right? And we've had outsourced hosting before. And we've had application service providers before. Who was around in the 90s, late 90s? Yeah? You guys remember application service providers, right? So I want to talk a bit about this idea of a utility. So we're going to drill down and talk a bit about cloud computing as a utility. We're going to talk in a bit of detail about platform as a service. And then we're going to run through a couple of example scenarios and then finally finish up talking about some of the issues that arise with cloud computing. This is a non-technical session, folks. If you want me to write some code, you've got to come to my session Wednesday, 400 level. I think it's the last session of TechEd. We're going to knock your socks off over in the theatre, but this is a non-technical session. So, posit for a moment that you're a startup business. Anybody in a startup business? Who's done a startup? Who's crashed a startup? Who's had a madly successful startup? Yeah, a few people. So, we built our startup. We're off to see the vulture capitalists. Right? Every good startup needs some vulture capitalists. And we said, we've done some modeling. This is what our application is going to look like when we go live. And therefore, we need to provision some hardware. What does that look like? Right, well, we make some capital investment up front. What's that capital investment for? Who wants to rattle some stuff off? Hardware, software, building it, cooling, floor space, rack space, right? Don't forget to capitalize all of those setup costs, actually putting these things together, right? And then we're going to increase our capacity as our demand increases in a stepwise fashion. Right? In reasonably large chunks, probably. The issue is that maybe we were a little naive in our original, our original estimation of what load's actually going to look like. Right? So maybe we don't have that nice linear load. Maybe we have a variable load. Right? Maybe this is a 6-month period. Maybe that's a 24-hour period. So what have we got here? We've got an area where we've got far more capacity than we actually need. Right? So we've got servers deployed, floor space taken up, rack space taken up. We've got these things plugged into the power or heating up the air. We've got them plugged into the cooling, right, so that we can cool it back down again. And actually it's wasted, right? We don't actually need that capacity at that point in time. At the same time, we have points in time where we have less capacity than we actually need to serve our customers, which means we deliver up a crappy experience. Right? And then we get this crazy drop in load here. Who's got variable load patterns in their business? Who's got completely consistent uniform load throughout the day, 24/7 by 365? What happened to the rest of you? Right? So what's the problem? We actually need a whole bunch more levers and knobs to better map our deployed capacity to the load against our application. And there are scenarios where you can tolerate a little bit of waste, right? And there are scenarios where you can maybe tolerate a bit of increased latency, right? But there are also scenarios where our difference between BAU and peak load could be 1 or 2 orders of magnitude. So we need, ideally, more levers and knobs to be able to solve this problem. Because we can't really solve it today. Right? Because it's very difficult for us to say, we want to procure computing resources for a short period of time. I want 200 servers for 90 minutes next Tuesday. Anyone sell me 200 servers for 90 minutes next Tuesday? Yeah? You'll send me 200 servers for 90 minutes next Tuesday from the green button? Right? So we need more levers and knobs. We want to better map our deployed capacity to the load in our system. We end up with a lower capital expenditure. Right? And that comes from the fact that we aren't procuring hardware. We aren't buying racks. We aren't buying cooling. We are still paying to get our application up into the cloud. Don't let anybody tell you that the cloud is a no CapEx solution. Right? So we still should be capitalizing that investment we make and actually getting our application up into one of the cloud computing platforms. If you're being really good, you should be taking a charge or at least allocating some sort of resource in the future for the fact that at some point you may have to get out of that cloud provider's platform. Right? You may need to decommission back out of that cloud provider's platform. So what do we have? We now have less capacity laying around idle. We have happy customers. We have a happy CEO. Right? And we have an ability to turn capacity on and off. Right? That may be throughout the year. That may be throughout the day. This is not enabled by any particularly fancy technology, folks. Right? This is enabled by providers working at utility scale. So I think it's really the economics that drives cloud innovation. Right? Cloud computing really allows us to purchase our computing resources in such a way that we can solve previously intractable problems. And I think it's really driven by these 3 broad characteristics. The first is that cloud computing is a utility service. That means it should be provisioned at a very large scale. And we're going to talk about the scale of provision shortly. Cloud computing gives you fast onboarding. Right? We can pick up and start using cloud computing very, very quickly. We work in small units of consumption. And again, we're going to talk about that on the next slide. And we're typically dealing with quite uniform offerings. Having those uniform offerings greatly simplifies our procurement, right? Because we are literally buying a standardized off-the-shelf offering. We're typically working with take-it-or-leave-it service level agreements. In most cases, the costs that we pay are fairly transparent pass-through costs with a margin of the costs that the provider is incurring. Right? We're typically looking at cost-plus type pricing in cloud computing, mainly because we have a very competitive market. Right? So we tend to have fairly thin margins available for those providers. That transparent pricing is really interesting because what it does is it helps drive behavior in your organization as a user of cloud computing and as an architect building applications that take advantage of cloud computing. We'll discuss that again shortly too. It is a low CapEx model. It is a low OpEx model. Right? Cloud computing is an inexpensive way to procure capacity because you are procuring it from providers who have it provisioned at scale. You consume cloud computing over the network, right? Typically through some sort of set of web standard interfaces. Right? So we're consuming these out of web services. We're consuming these with RESTful web services. If you look at any of the major cloud vendors, Microsoft, Amazon, they're all dishing stuff up across web services. Right? We kind of have a standard for infrastructure as a service. Who can tell me what the standard for infrastructure as a service for virtualized compute? The x86 processor architecture, right? It's been around for donkey's years. If you buy a virtual machine instance from someone like Amazon, what are you getting? You're getting the ability to run a virtual machine for an hour. So I like to draw a bit of a comparison between generators and the national grid. If you run your house on a generator, say a 2000 kVA generator, and you plug your kettle in, your 2.5 kilowatt kettle in, what's going to happen? Boom, right? It's going to trip. If you plug your kettle into the wall socket, what's going to happen? You have a nice cup of tea, right? Why is that? It's because the national grid has additional capacity that's available, right? It has excess capacity that we can consume when we plug our kettle in. Right? How's it got that excess capacity? It's got that because it works at really large scale. What do we do if we want excess capacity in our own scenario for our house? We buy another generator, yeah? What do we pay to have excess capacity in the national grid? Maybe a small amount extra for each unit of power. What would we pay to have excess capacity so that we can run our kettle at home? A couple of $1,000s to have that generator. What if it's going to sit around and do nothing most of the day? Right? Very expensive for us to have, the costs for us to carry that excess capacity are really, really high. So, what are some of the things that really drive this idea of computing as a utility? The first is that cloud computing is deployed at a very large scale. I like to talk of cloud computing as being deployed at orders of magnitude larger than your single largest customer. So if your largest customer deploys 100 CPU cores, you probably want 10,000 CPU cores. What's the benefit of having that scale? Well, the benefit is that our costs to carry additional capacity to deal with things like spikes in load are amortized across a much broader number of customers. So whereas in our generator scenario, our costs to carry an additional 2.5 kilowatts of power for our kettle was amortized across us, i.e. we incurred that whole cost. With the national grid, that cost to carry is spread across all of the customers in New Zealand. Right? And they don't have 3 million times 2.5 kilowatts spun up at any one point in time. Right? They rely on the fact that actually this load tends to balance itself out over time. We consume this in small units of consumption, and that means that we can really right-size our capacity in near real time. If you think about these two, what's our unit of consumption for the generator scenario? A generator. Right? What's the unit of consumption for the national grid scenario? A kilowatt hour. Right? So we can far more accurately match our deployed capacity to the capacity that we actually demand. You have limited scope for negotiation of terms. Who's renegotiated anything with their power supplier recently? Not a lot of people. You usually have to be quite a big consumer to renegotiate your power contract. If you own an aluminium smelter, it's usually a good starting point. Right? What does that do? Well, it reduces the cost of sale for your provider, right? Because you're probably going to take a whack if you need to get Chapman Tripp or Russell McVeigh or any of those guys involved to try and renegotiate the terms of your contract. Right? So it reduces that cost of sale, therefore it reduces your cost of procurement. Right? So given that we're consuming probably reasonably small amounts of resource, right, we have a low transaction cost when we come to procure that. Right? So at the end of the day, only the largest customers are going to be able to negotiate. And there probably is scope for negotiation for really big customers. If you're using hundreds, thousands of CPU cores each month, then there will be some scope for negotiation. It's a low capex model. Right? So cloud computing is typically provided on a service with no upfront costs. You will need to capitalize your onboarding costs. Right? You'll typically not be required to sign into some sort of long-term contract. Right? And that, to be honest, differentiates what I would call the smaller scale cloud computing providers, right, who are really the virtualization folks calling themselves cloud because it's trendy, right, and real cloud computing providers. If your cloud computing provider says, we want you to sign up for a 12-month contract, you probably want to start scratching your head and wondering why that might be the case. That said, some of the providers are having models that support an upfront payment to reduce your ongoing costs. And we typically have transparent cost-plus pricing. And what do I mean by that? Right? If you pull power off the national grid, right, what are some of the interesting things that happen? The power price actually fluctuates. Right? What's that telling you? It's telling you that the cost to provision that kilowatt hour at that point in time is higher or lower throughout the day. We're going to start seeing some of that flow through into computing as well. Right? So, the costs that we see from our cloud computing providers give us an indication of the costs that they incur to actually provide that service. Therefore, we need to architect our application against that cost model. And a lot of people find this quite offensive to their sort of puritanical view of software architecture, but you need to be architecting your app for the pricing model. Right? Because there are many very counterintuitive aspects of consuming cloud computing. One good example is that, and I can do you some pretty good models around this, in the Windows Azure platform, it often makes sense to massively duplicate your data. And the reason you're massively duplicating your data is to minimize the amount of resource you have to spend querying that data back out. Right? So storage is cheap, processing time is expensive. And it's really important, right, that we pass these costs as deeply into our business as we can. People often talk about the private cloud. Has anyone heard about the private cloud today? Anyone heard about the private cloud before? Right? So if you're going to think about a private cloud is not particularly interesting until you actually have an internal accounting model. Because if you have a private cloud, what you're trying to do is you're trying to say, right, as an organization, New Zealand government, for example, we're trying to come up with a model where we can have X big block of computing power, and we can actually balance all of our workloads across that, right, so that we take advantage of our underutilized capacity. We want to move those workloads around. Right? So we need to have those cost signals flowing through in order to encourage people to move those workloads around. Until you have if you start applying this as an overhead charge, what are people going to do? Exactly what they do at the moment when you apply it as an overhead charge. Right? Have 100 servers, each of which is running at 3% capacity. So we need to actually encourage people through economic signals to change their behaviors in terms of software architecture and in terms of application usage. What are some of the key sells to your CFO? So he's going to have minimal capital expenditure to consume this. He's potentially going to have a more predictable gross margin. How's he going to have a more predictable gross margin? If you have an application that has a fairly predictable average revenue per user, cloud computing is going to give you a far more predictable average cost per user. Right? It's going to be far easier to model what it costs to carry each user per month. Because you haven't got this spiky consumption graph where you're having to buy things in big chunks. Your financial risk only increases as the business value is proven. Right? That means we don't have to go and buy a whole lot of stuff up front and incur a huge risk if the business venture actually proves to be a failure. We don't have stuff sitting on our balance sheet, so we don't have stuff to write off or write down, and there's no need to depreciate those assets. Key sells to your CEO. Obviously, no call on equity capital, no call on debt capital. Right? Minimizes his capital investment. CEOs are big for crazy ideas. Anyone got a crazy ideas CEO in their organization and is prepared to admit it? Right? They come up with great ideas, and those ideas are either really fantastic or they're a complete disaster. Right? So we want to be able to enable that to happen. So we want this idea of, scale fast or fail fast. Fail fast can't cost the earth. And we can refine our strategic focus, so reduce our headcount on non-core functions inside our organization. So when we think about consuming cloud computing, we're typically going to be consuming it at one of these three layers of the stack. At the bottom layer, we have infrastructure as a service. Infrastructure as a service is really buy as you go, virtual machine hours, and storage. The beauty with infrastructure as a service is you can run anything you want. Run whatever operating system you want. Put whatever applications you want onto it. Right? But it is still pay as you go. Right? So you're going to pay 10 to 15 cents per hour. The challenge is that you're going to need to manage all of those machines and resources that you spin up. So if you spin up 1,000 machines, you actually need to have the technology in place to manage 1,000 machines, just as you would if you had 1,000 machines in your own data center. If we start climbing up the stack, and one of the interesting things with this idea of the stack is that you can potentially build any one of the higher layers in the stack on top of any one of the lower layers in the stack. So we start climbing up the stack, we look at a thing called Platform as a Service. And Platform as a Service are pay-as-you-go building blocks for building internet cloud scale applications, for building high-scale, elastic, highly available applications. Right, they provide us with a much higher level of platform construct. We're no longer thinking in terms of virtual machines. We're no longer thinking in terms of traditional server operating systems. Right? It's designed for scale out from the get-go. The challenge here is that it's hard to move existing apps to the cloud. Right? Yes, we can pick up an app, we can throw it on a single box in the cloud, infrastructure as a service. But if what we're moving to the cloud for is 1,000 boxes, all acting in concert to run our application, right, we either need to hopefully be well architected from the outset, right, or we are going to need to make some architectural decisions in order to make our application cloud ready. Software as a service are pre-packaged services, right? This is basically software that we can buy that's delivered to us over the internet. It lowers our barrier to entry for purchase, right? It allows us to flexibly add and remove users from our application. Right? So we rock up with our credit card and we buy X number of seats of Xero for the month. Anyone use Xero? Right. Xero, good example of software as a service. Microsoft's BPOS offering, good example of software as a service. So we're going to drill down a bit on this idea of platform as a service. And to do that, we're going to start by talking about what I call the strategic advantage cloud workloads. Right? If you can identify workloads that look like these inside your organization, there's the potential to deliver strategic advantage to your business more than just incremental improvement. So in the top corner, we'll start with on-off workloads. These are batch workloads, the need to spin up significant capacity to perform some sort of processing task and then turn it back off afterwards. Some good examples of this, things like financial batch processing. I need a supercomputer for 3 hours at 2 o'clock every morning. This starts to get really interesting when we start seeing innovation around pricing models where we have things like spot market pricing. So I have a workload that arbitrages the stock market. And I can make money when computing power drops below 4 cents per CPU core. Therefore, I can upload my workload into the cloud and tell it to only run that workload when the cost of compute drops below 4 cents per hour. The growing fast pattern. CEOs come up with a brilliant idea. Takes off, hits Slashdot, right? Gets tweeted. Hits Facebook, Bebo, MySpace, Foursquare, right? Any the social networks up the wazoo. Now we have a problem. So the CEO has entrusted us as technologists to make sure this thing can deliver going forward. And we call up all the major hardware vendors and they tell us there's a 10-week lead time for servers to get them air freighted out of Malaysia. We now have a bit of a problem, right? And that we are unable to scale. We simply cannot provision hardware fast enough to deal with that demand. At the same time, if this thing was a complete disaster, we probably didn't want to have lots of hardware sitting around in the first place. Right? So our ability to turn on capacity really, really quickly is a big benefit there. Unpredictable bursting. The Michael Jackson fan club site. The day that Michael Jackson died. Right? Now, if they were selling online advertising, they either made a lot of money or they looked like a real pack of wallies. Totally unexpected and unplanned peaks in demand. Very hard to deal with. Has anybody been hit by this? Anybody been slammed? Nobody's been slammed. One person's been slammed. Good. Right? So sudden news events, sudden events driving load to your application. Predictable bursting. My hope is that everybody will have at least some scenario where predictable bursting applies. The canonical example is online ticketing. Anyone go to rugby matches? Right? So online ticketing. Most of the time they can get by with a couple of servers, right? They might be selling 10, 15 tickets per hour. The All Blacks versus South Africa goes on sale, right? And despite the result pretty much being preordained, it's wildly popular. So it goes on sale at 9 o'clock in the morning. What's going to happen? 8 a.m., everybody's there, F5, F5. Oh, when's this thing going to go on sale? What's that doing to your database? It's obliterating it. What's it doing to your application tier? It's obliterating it. Right? What do you really need to make that work? Heaps of servers. What's the problem? You only need them about 3 times a year. So how do the ticketing companies solve this problem? They don't, right? They sort of throw their hands up and say, oh, well, yes, it was busy. We knew it was going to be busy, but we kind of couldn't afford to fix it, right? What are some of the other common scenarios where you'd think about, and these are, none of these are really technology problems, right? We know how to build an application that scales out to sell tickets, right? Piece of cake. What we don't know how to do is how to have 200 servers for 90 minutes, 3 mornings a year. It's all about economics, folks. So what are some of the other scenarios? High availability. So having high availability applications at a reasonable cost. High availability SQL Server. Who wants to posit a guess at number of zeros? Right? How about 2 figures to provision high availability SQL Server? 3 figures? 4 figures? 5 figures? 6 figures? Anybody awake? 6 figures? 5 to 6 figures? 6? Yeah? If I said you could have high availability SQL Server for $10 a month, would you be pleased? So the thing about this cloud computing carry-on is one of the side effects of building for sort of scale out is you actually build high availability in at the same point in time. So both Windows Azure Storage and more importantly, Microsoft SQL Azure are high availability offerings. Each comes with 3 transactionally consistent replicas of your data spread throughout the data center at any one point in time. Right, so SQL Azure is a true transactionally consistent high availability database that starts at $9.99 US per month. Massive scale, right? These things can be really big. How can they be really big? Well, the data centers that we deploy them out of are really big. So if you have apps that have a large global user base, online gaming, massive multiplayer online games, social networks and so forth, right? They're suited very well to the economics that are offered by cloud computing providers. Highly variable load, we just spoke about that, right? Both predictable and unpredictable bursting. Big differences between peaks and troughs, right? Online ticketing, the difference between peaks and troughs is roughly 2 orders of magnitude. So you can potter on along on 2 servers most of the time. You need 200 servers to deal with that peak period, right? Impossible to do from a financial standpoint without cloud computing. Short-lived apps. You're going to run up an app just for the half-time break in the rugby. All right? You're going to try and capture all these people who sit and watch the rugby with their laptop on their lap and tweak the thing. you know who you are, right? You want to capture them. So you want to basically drive a marketing campaign, an advertising campaign with online interaction during the halftime break in the rugby. Wouldn't it be quite nice to be able to spin up all the capacity you need for that 1 hour period and then turn it off afterwards? Scale fast or fail fast. We've spoken a bit about that already. Stealth apps. I'm kind of reticent to talk about that in this esteemed audience. But stealth apps allow you to deploy stuff maybe without, strictly speaking, going through all of the very important and fundamentally necessary change control processes that might otherwise govern IT procurement. Right? You want to get something up and running quickly. This is a pretty good way to get something up and running quickly. Right? SQL processing. So this is a bit of an interesting one, and I actually, this is a reasonably late addition to this slide deck, but it came about because I had some discussions with a colleague who's actually a barrister. And he called me up and he said, I've got a problem. I've got Company A, and Company A collects data about wind speed at the tops of hills. And I've got Company B, and Company B writes sophisticated algorithms for processing wind speed data. And Company A doesn't want to give their data to Company B, and Company B doesn't want to give their algorithms to Company A. How do we solve this problem? And what we really need is some sort of trusted third party to actually be able to perform that computation for us. Right, so cloud computing helps to solve that problem as well. So let's talk about a couple of case studies. So the first one is an application that we built for a crowd called Curtin University. And they are based over in Western Australia, and they have an application called iPortfolio. And iPortfolio is a way that students can keep a repository of all of the artifacts they built up during their time at university. Now, for old schooler university people like me, that's not just things like Word documents, because these new schoolers, they have things like flip HD cameras that they take out on field work, right? And they start amassing all sorts of interesting resources. So Curtin have said, we'll let you keep these resources and we'll hold on to them for you for the rest of your life, so that you've always got a complete record of all of the effort and work and output that you came up with when you went through university. That's a pretty strong commitment to be making. That sort of a commitment requires that you probably have fairly reliable storage, right? Sticking it on some SATA drives underneath somebody's desk is probably not going to cut the mustard, right? You probably need to think about backup, but actually you're not guaranteeing to back this data up, right? You're guaranteeing the data will always be there. You're not guaranteeing that you'll be able to go back and say, we'll give you a point-in-time restore. So, up until now, Curtin actually stored this information on their SAN. And as you can imagine, we've got a 15,000 student university, graduating 3,000 or 4,000 students every year, all of whom are collecting resources here. Our storage requirements are growing massively. So they wanted to go off that SAN storage and come up with a better approach. So we decided we wanted reliable storage. We were comfortable that the data stored in triplicate in Windows Azure storage was reliable enough, i.e. we're not going to lose that data, right? We don't need backups anymore, right, because we have reliable storage. It is significantly cheaper than what we could provision on-premise storage for, right? This is going to cost us 15 cents per gig per month. That means it's at the sort of price point where we can afford, right? Notice I'm talking dollars and cents here, folks. Price point where I can afford to deliver the sort of application I want to build. Because on the SAN storage, I couldn't afford to deliver the sort of application I wanted to build. So we actually split out their application, kept the legacy Cold Fusion stuff on premise, pulled the data upload and resource processing, things like video re-encoding, portion of the application up into the Microsoft Windows Azure Data Center in Singapore. Right? And by doing that, we actually allowed them to now go forward with this application and expand it out broadly across their entire student body with that commitment that they'll hold this data in perpetuity. Pretty compelling scenario. Okay, I've already spoken a bit about ticketing because this is the canonical cloud example, right? Because the ticketing providers simply can't afford to provision hardware for those peak periods. Because it literally is 3 or 4 mornings a year where they have this high load, right? And the rest of the time, they can get away with a couple of servers. They have orders of magnitude difference between business as usual and peak load. We wanted to be able to sell a 120,000 seat stadium out in under 20 minutes. Right? Now that's pretty hard to do. Right? That's a fair load of transactions. And yes, there are some upstream providers who rely on. So we needed to be able to scale elastically, right, turning capacity on and off the entire application. The application tier is pretty simple. Right? We use Windows Azure. Windows Azure allows us to turn on and off instances on an hour-by-hour basis and pay 12 cents per instance per hour. So we'll turn on 1,000, and that's okay. We've probably got 5 times more capacity than we need for the hour, but we actually don't care whether it costs us $12 or $120 to sell out this stadium because it's a drop in the ocean, right? But we also need to scale the data tier, right? Because we need a true transactionally consistent database. And why do we need that? Because we need to make sure there's only one backside per seat. All right? So the guys at Ticket Direct have a bunch of pretty sophisticated stored procedure logic that's been built up over the past sort of 7 or 8 years that does seat allocation and does pretty effective seat allocation to make sure we don't leave single seats, 1, 2, right? Like you do at conferences. We don't do conference-based seat allocation. We do highly optimized seat allocation, right? All tied up in stored procedures. So we needed a true database. So what we do is we actually scale the database as well. Because SQL Azure we can buy on a day-by-day basis, right? It's $9.99 per month, prorated by the day. So it's about 10 to 15 cents per day. 4 cents per day. Not a lot of money, right? So what we do is actually just before game day, we take the one database that normally sells all the tickets and we chop that database up into 50 databases. Basically one database for each portion of the stadium. We then sell the seats out of it, and then after the sales period has finished, we consolidate those databases back down again. So cheap is SQL Azure when used like this that we reckon we could afford to have one database per seat in the stadium and still make really good money. Now obviously one database per seat in the stadium is not particularly effective because actually the whole point of having a database here is we want to have transactions that can span the boundary of multiple seats because you usually go with friends, right? But this is a really low-cost approach for solving this problem. This problem is previously totally intractable, right? You simply cannot afford to solve this in any way other than cloud computing. So we spoke a bit earlier about this idea of the Slashdot effect, right? And this is a real example with the names changed to protect the innocent. So you're the Port of Timbuktu, and you provide a webcam and tide chart website that's typically only ever used by the windsurfers and the kite surfers, right? But then one day, something happens on Twitter, right? And that drives a whole lot of people to maybe go to Bing. And that drives a whole lot of people to maybe come and visit your website. And suddenly it falls over. Right? And this is actually something that has happened to someone. Right? But we have a cloud data center. So we really want to take advantage of that cloud data center. We really want to move that load from the Port of Timbuktu server to our cloud data center. But I want to be able to do it for $5. All right? And I use a little bit of a sleight of hand here. Who thinks I can do it for $5? Who doesn't think I can do it for $5? Who's still awake? Right? So I use a bit of a sleight of hand here. I'm going to do this without using any compute capacity in the cloud, because actually I already have a perfectly working application here on premise. Right? Works really well. The only time it doesn't work well is when there's a tsunami. How often are there tsunamis? Not very often. Right? So I don't want to spend a lot of money, one, porting my application to the cloud, and two, I probably don't want to have a server sitting here doing nothing while I'm also paying for instances up in the cloud when they're really not doing a lot either. So how do I do it? I basically write myself a little spider, and I push constantly copies of my website up into the cloud. Right? I push them up into Windows Azure Blob Storage. The nice thing about Windows Azure Blob Storage, as we said earlier, is it's based around open internet protocols. It's a RESTful web service. What happens when you do an HTTP GET at a RESTful web service? You get the data that's at the RESTful web service back. That means Windows Azure Blob Storage is basically a static web server. So what I can do is, given that I'm actually not too worried if this is maybe 30 to 60 seconds out of date, is every 60 seconds I can push the webcam picture and the tide charts up into the cloud. And instead of serving the application out of my server, I actually serve it out of the cloud. Right? That means for about $5, I can have an enormous web server in the cloud to deal with any sort of load I throw at it. Right, so the users just hit that blob storage and it's treated as a static web server. Blob storage gives us roughly 60 megabits throughput. If we find that we need more than 60 megabits throughput, we go to the Windows Azure portal, we tick a checkbox which turns on the content delivery network for our Windows Azure storage account, and we then have a 20-node CDN with servers around the world to serve up our data for us. Right. This is infinite capacity on tap. If your application can tolerate 30 to 60 second staleness on data, this is a pretty good scenario. Election results. This could be a pretty good scenario, right? We don't mind if they're maybe 30 to 60 seconds old, but I'll tell you what, I know that when the Aussie election was on, I was sitting there with an F5, F5, F5 on my keyboard, refreshing their electoral results site. So let's do the math. So pushing the data up, I worked on the basis that we had 3 webcam images and 1 tide chart, each at 50K each. We push them to the server every 60 seconds. That gives us 0.002 gigs per minute for 43,200 minutes per month, which is roughly 8.64 gigs at 15 cents per gig. Gives us $1.30 for the month. Now I am at the moment ignoring the outbound traffic from our own data center, which is a little naughty, right? But it gives a pretty good example, right? Getting the data back down. I work on the basis that for off-peak usage, we get 1 hit per minute, which is probably far more than we realistically would. And that costs us, therefore, roughly $1.30 a month. For peak, assuming that every person in Timbuktu with a population of about 50,000 hits the site once, we pay $1.50 to get it down too. So therefore, for well under $5, right, we're able to solve this problem. Does anyone think that's rather interesting? Has anyone looked at it that way before? Did you have a question? No? Right? I mean, this is like, it's just really weird economics. You would never have thought of it like that before. You'd never have thought of solving the problem like that before. You'd never thought it would be that cheap to solve the problem. Right? You were a bit of out-of-the-box thinking, and the fact that cloud computing is very much a pure utility for us to consume, we can solve that problem very, very easily. So, rose-tinted spectacles off now. There are, however, some challenges. Cloud computing security is obviously going to be one of them, right? Who has issues with cloud computing security? Lots of people. I'm not too concerned about cloud computing security. Who thinks they're pretty secure at the moment? Not a lot of people, right? Because when it comes to IT security, the easiest way for me to knock you off is actually not to hack your systems. I make a trip to Mitre 10. Anyone from Mitre 10 here? No. Right? I'll get myself a sledgehammer, a chainsaw, and a SS Holden Ute. I will come to your office 2 o'clock in the morning, smash a hole in your front door with my sledgehammer, walk up to your server room, cut a hole in the front door with my chainsaw, pick up your server, put it in the back of my ute, and take it back to my evil lair. Right? That's how I'm going to knock you off. You think you're going to knock off a cloud computing data center like that? 24 hours a day they're manned. They have people with guns. Right? I can't even buy a gun in New Zealand. Right? The guys running the cloud computing data centers, right? They have the smartest security engineers in the world. Why do they have the smartest security engineers in the world? One, they can afford to pay them lots. Two, the smartest security engineers in the world don't want to work for your 12-man IT team. They want to work in a data center that's got 35,000 CPU cores, because that rocks their socks off, right? So they have the smartest people. They have scale where they can afford to have Gallagher electric fences, right? Where they can afford to have people with Glocks. So they have all of these things that deliver qualities of scale. However, this one's a little more interesting. Who has concerns about data sovereignty? Right? Data sovereignty is what legal jurisdiction applies to my data. If it's in Singapore, what legal jurisdiction applies to my data? Singapore law? What if the company that owns the server in the data center is actually a Belgian company? Still Singapore law? What if that Belgian company has a sales office in Reno, Nevada? Does the US Patriot Act apply to it? Can we get a sneak and peek warrant to go and have a look at that for a US federal agency? Think you can find a QC in the country who'll give you an illegal opinion on that? No? Right? Very, very hard problems to solve, right? This is extremely complex operation of conflict of laws because you are dealing with multiple jurisdictions. Which privacy law applies? Right? I want to store some health data up there. Which privacy law applies? Singaporean privacy law, Belgian privacy law, New Zealand privacy law, American privacy law. There is no answer to this problem, unfortunately, folks. The only answer is that you need to go in with your eyes wide open. Right? You'd think the Ministry of Foreign Affairs and Trade would probably have different things that they will consider about data sovereignty than Ticket Direct. Right? So you need to go in and actually understand what does the risk profile look like for my business, given that the risk is an unknown risk. Right? What risk am I prepared to carry? There are a bunch of other risks around cloud computing. Abuse and nefarious use of cloud computing. If I want to obliterate your application, what am I going to do? Stolen credit card, and I'm going to build a distributed denial of service attack client using somebody's cloud computing system. I don't need a botnet. I can buy a botnet for 12 cents an hour, right? On somebody else's stolen credit card. Yeah? So you need to be conscious of that. Insecure interfaces and APIs. These nice open sort of web standards APIs are all well and good, but they are somewhat easy to make mistakes around. Right? It is actually fairly easy to accidentally end up with a whole lot of data that's just open for public download on your RESTful web server if you're not careful. Right? There's not lots of layers of sort of secure by default complexity to protect you from yourself. Malicious insiders. We now have multiple organizations that can potentially be vulnerable to malicious insiders. Right? Some of these are common problems across not just cloud computing, folks. Data loss or leakage. How do we even know that we're losing data? If we're losing data from a Singaporean data center or a Hong Kong data center, and it never goes anywhere near New Zealand. Account or service hijacking. If your account or service is hijacked, people can potentially do bad things. If your account contains things like an SSL certificate, right? Because you may, if you need to use SSL, have to upload an SSL certificate including the private key into the cloud. People can do an enormous amount of damage if we end up compromising your SSL certificate. And the unknown risk profile. Right? Again, things like data sovereignty, where there are really no answers. Right? How would we normally solve I mean, the data sovereignty problem is kind of unique to IT in some regards, because if it was any other industry, right, we'd solve it by creating an international treaty. The problem with international treaties is that they don't really work at IT-type speeds. Yeah? We could do something like the World Trade Organization and have the Doha round, and it could take like 15 years. Right? And by then we'd all be long in the tooth and we'd be gone talking about the next thing. Right? So it just doesn't work. The traditional models of solving these complex jurisdictional issues just don't work at the speed at which IT innovates. Some other issues, bandwidth. So if we think about taking an application out of our data center and pushing it into the cloud, we may have a situation where we're actually requiring significantly more bandwidth because we have to push data into and out of that application all day long. The classic example here is email. Right? If you push your email into the cloud and you're the sort of organization that does email as a file system or email as a file transfer system, everybody's nodding, right? Then you are going to increase your bandwidth. However, you may well have saved some money in decommissioning your on-premise services, and you can pick up some of that capital and reapply it towards having better internet connectivity. And by doing that, that better internet connectivity improves not only your email, but also many of the other aspects of your IT business. Integration. Integration with the cloud is hard for two reasons. One is we're over high latency connections, right? So we don't have an ability to do high performance real-time integration. And two, real-time integration is potentially fraught with a lot of problems. Who wants to think about what one of those problems might be? So it's awfully tempting to say, right, let's put this application in the cloud and we need to integrate with our on-premise system, so let's make a web service call. And then let's scale our application in the cloud up to 1,000 nodes. And then let's see what that web service call starts doing to our on-premise systems. Right? You've just built yourself a distributed denial of service attack client. Right? So when we think about how we solve the integration problem, we really need to think about integrating in an asynchronous fashion. And there are a bunch of interesting tools to be able to do that, right? Things like Windows Azure App Fabric, right, allow us to have things like message buffers and buffered and queued type mechanisms to prevent us from tearing down our application by scaling up in the cloud and not scaling up on-premise and having that synchronous integration point. The long-term viability of your service. Right? To what extent do you know that the service that you're now taking a dependency on is going to be around for the long haul? Right? To what extent, if someone offers you this fantastic new platform to build out that's currently in beta, and then they go, oh, actually that wasn't very good, so we might can it. Right? And yes, even large organizations do that. Right? So you need to look at what is the long-term viability of that service. Has it got out of beta? Right? Because as a general rule, organizations, once something leaves beta, they will actually take a commitment to looking after you, right, and not dicking you around. You know, if you had built something on Google Wave, you were probably potentially quite peed off right now, right? Because yes, it was in beta, and they just whacked it, right? You know, what do you do? So you need to have some confidence in the longevity of your provider before you go and pick up their platform and take a strong dependency on it and invest a lot of money in it. Data sovereignty, we've spoken about that in some detail. Data recovery. If I'm putting my data in the cloud, how can I be sure I can get it back out again? More importantly, if I get pissed off with my cloud computing vendor, right, because I don't like their security policies, I don't like the way they treat me, and I say, I'm leaving you, please delete all my data. How do you know they've deleted it? If you leave them because you don't like their data retention policy, you've got a bit of a problem, right? So make sure you ask these questions up front. Think about these challenges up front. Standards. Lots of wailing and gnashing of teeth around standards. I am not a big fan of premature standardization, folks. Premature standardization kills innovation, right? We have standards in some places, right? We have sort of emerging standards in the infrastructure as a service space. We have pretty well entrenched standards in terms of the x86 processor architecture and infrastructure as a service space, right? Platform as a service, do we want premature standardization there? If I look at the Windows Azure, platform as a service offering, is totally different to Google App Engine as a platform as a service offering. Totally different ways about thinking about solving problems. Right? I don't want to try and force standards in here too quickly. How and when do we do this? Right, so tactically there are some low-hanging fruit. Right? Some of the software as a service offerings really are low-hanging fruit. Microsoft BPOS is a bit of a no-brainer for most organizations. There is strategic opportunity, right, where you can deploy PaaS to take advantage of some of those interesting workload patterns. If you have one of those strategic workflow patterns, on-off, scale fast, unpredictable bursting, predictable bursting, there are opportunities for you to deploy platform as a service cloud offerings for strategic advantage for your business. Ensure your apps have cloud-ready architectures, so make sure you are in a position to be able to deploy into a scale-out type platform. Make sure you are in a position to be able to take your data and partition your data without manifestly affecting the operation of your application. Start managing ICT as a service now, so make sure you have internal cost accounting. Right? Start apportioning those costs out to portions of your business based on usage. Right? Because that's going to put you in a position to be able to start encouraging people to change their behaviour in terms of how they use ICT. Review your asset register and look at what in your application suite could potentially be moved onto a cloud-based migration path. Please make sure you complete an evaluation on ComNet and enter to win. We have approximately 4 minutes left for questions, and after that I will go and hang out in the Cloud Lounge and take questions as well. So with that I will open it up to the floor. Absolutely. So the question was, you talked about on-demand, but can you set it up so you just like scale magically? So the answer is yes. If you want a practical example of it, go to Codeplex and search for Windows Azure Auto-Scaling. My team and I wrote an MSDN white paper which actually shows how you can pick up Windows Azure and monitor things like queue length and monitor things like request latency to automatically scale up and down in Windows Azure. So the answer is yes. There are some limitations around at the moment. We'd like to be able to do things like query the billing engine. How much have I spent this month? Stop scaling when I've spent $5,000. Right? Can't do that quite yet, but certainly being able to scale up and down automatically based on load, yes, pretty easy. Crikey. Was that useful? Please do fill your evals out. I will be across the air bridge in the Cloud Lounge, so come and hang out with me. Might be some Windows Azure product group folks over there as well. Thank you all for coming along and look forward to seeing you later in the week.